Hey guys, welcome back to another math lesson with HK Math and Science. In this video, we'll be learning about simultaneous equations and how to solve them using the process of elimination. So by the end of this lesson, we should be able to add or subtract two equations to eliminate one of the variables, know how to obtain a matching pair in simultaneous equations, and also be able to use elimination to solve simultaneous equations. So just pause the video here and take a couple of minutes to write these down. Alright, so let's just start off by going through a couple of key ideas of this lesson. So the first of these is that elimination involves the addition or subtraction of two equations to remove one variable. And also elimination is often used when both equations have the form, either something like this, ax plus by equals d, or something similar to this, ax plus by plus c equals 0. So I've got a couple of equations down the bottom here, or examples, that take the form of this first equation here. So we have 3x minus y, that's the same as 3x minus 1y, so the 3 would take the spot of the a, and that's 1y, so that 1 here would take the spot of the b here. Same with the bottom one, 5 would take the spot of the a, and a 1y would take the spot of the b. Same with this one on the right, the 2's will take the spot of the a, and the 3 and the 5 would take the spot of the b. And to use elimination in simultaneous equations, we need to find a matching term. So there's matching terms y's here, 1y's, and two x's here. If they have opposite signs in front of them, like in this case a negative y and a positive y, we need to add the equations to eliminate the term. So if you add negative y and positive y, that's going to give us 0, so we can cancel those out. So 3x, that leaves us with 3x plus 5x, and that gives us 8, and 4 plus 4, which also gives us 8. On the right though, we have the matching terms 2x. They have the same sign, they are both positive, so we need to subtract them to get rid of them. So those two cancel out, and we have positive 3y minus negative 5y, and when you subtract the negative, that becomes positive. So 3y plus 5y, that's its equivalent. So 3y plus 5y gives you 8y, and 6 minus 7 gives us negative 1. So that's how we got to these equations down the bottom. So this will make a bit more sense when we go through these examples here. So let's start with the one on the top left. We have x minus 2y equals 1 and negative x plus 5y equals 2. So they're two separate equations here, and we can solve them together. So let's use the first method here, add equations to eliminate the terms just because they have opposite signs. Notice this one is a positive and that one's a negative, so we can add them together to get rid of them. So if we add these two there, that's going to give us, that cancels these two out, and then we have negative 2y plus 5y equals 1 and 2. Add those, negative 2 plus 5, that gives us 3y equals 3, and now we can solve for y. Just divide both sides by 3, and y will be 1. So now we've solved for y, that's half of the question. We have y equals 1. We also need to solve for x. So we're going to just substitute the value of y into one of these equations. You can pick either one, you'll get the same answer. So I'm just going to pick the top one because this one's a negative and it's easier to work with positive. So let's substitute that in. X minus 2 times 1, because we're substituting 1 into y, equals 1. So x minus 2 is going to give us 1. And I'll just bring the working out over here because I'm out of space there. X minus 2 equals 1. And we're going to bring the negative 2 to the other side by adding 2 on both sides. That gives us x equals 3. So our final answer is y equals 2 and x equals 3. Now let's have a go at the question on the top right. We have 3x minus 2y equals 5 and 5x minus 2y equals 11. This time they're the same sign on both of the questions or equations. So we're going to use the second method here, subtract equations to eliminate terms of the same sign. So we're going to put a subtraction sign just up here. So 3x minus 5x, that is going to give us negative 2x. Yeah, and negative 2y minus negative 2y, that's the same as negative 2y plus 2y, that gives us 0, so we're going to cancel that out. And 5 minus 11 gives us negative 6. So we now have negative 2x equals negative 6. Now let's get rid of the negative 2 on the left, so we can do that by dividing both sides by negative 2. And that will give us x equals 3. So we know half of the question now, x equals 3. We can substitute that into one of the equations to solve for y. So I'm just going to do the top one again. You can do the bottom one if that's what you want to do. So substitute 3 into x, so 3 times 3 minus 2y is going to give us 5. So 9 minus 2y equals 5. We need to bring the 9 over here. So that gives us negative 2y equals 5 minus 9, or negative 4 equals negative 4. I'll bring the working out up here. Negative 2y equals negative 4. Divide both sides by negative 2, and that will give us y equals 2. So our answers here is x equals 3 and y equals 2. Welcome back. Let's try the one on the top left. So they have different signs here, so we're going to add them together to cancel it out. So negative x and x, they can be cancelled out by adding them. And then we have plus y minus 2y. That's going to give us negative y equals 1 minus 3. That gives us negative 2. And we need to get rid of the negative sign on the left because we just want to find out what y is. Y equals 2. So now let's substitute y into the equation. I'll just do the top one. Negative x plus 2 equals 1. Negative x equals, we're going to subtract 2 from both sides, so that gives us negative 1 here. So x therefore equals 1. So your two answers are y equals 2 and x equals 1. Give yourself a tick if you got that correct. And now let's have a go on the question on the top right. We have the like terms over here and they have the same sign, so we're going to subtract it this time. So 4x minus 3x gives us x, and negative 3y minus negative 3y is the same as negative 3y plus 3y, so they're going to be cancelled out. And now we have negative 16 minus negative 15, so that's the same as negative 16 plus 15, and that's going to give us negative 1. So that was pretty simple. X equals negative 1. Now let's, sorry, that's just my puppy. Now let's substitute negative 1 into one of these equations. So 4 times negative 1 minus 3y equals negative 16. So negative 4 minus 3y equals negative 16. We can we can add 4 on this side and that side to get rid of the negative 4. So that will give us negative 3y equals negative 12. And divide both sides by negative 3. Sorry, that's my puppy again. That will give us y equals 4 there. Give yourself a tick if you got these two correct. So your answers are x equals negative 1 and y equals 4. Before we move on to the next few examples, we need to go through another key point, and this is that sometimes terms cannot be eliminated just by using addition or subtraction like we've been doing in the previous slides. In these cases, we need to first multiply one or both the equations to form a matching pair. So we do this when we don't have a matching pair. So in the previous ones, you can see there's a matching pair here, there's a matching pair here, the ones we're cancelling out, and there's a matching pair here and a matching pair here. But in these next few ones, there aren't any matching pairs. You can see in these two equations there isn't a matching pair. So we need to multiply either one of the equations or both of them to get a matching pair. So in this case, we only need to multiply the bottom one here, and that gives us 4x plus 2y at the bottom, and then we have a matching pair of 2y there. Same with the bottom one's a little bit different. There are once again no matching pairs down here. In this example, it's kind of like getting the same denominator when adding and subtracting fractions. So they multiplied the top one by 4 and the bottom one by 7, so that will give us 28 and 28 here. This might make a bit more sense when we go through the next few examples, but just pause the video here and take a couple of minutes to write these notes down. Alright, so let's have a go at a couple of example questions. So in this case, the easiest way to get a matching pair is to multiply the bottom by 5, because that will give us 5x over here. So the top one stays the same, 5x plus 2y equals negative 7. We don't need to do anything to the top one. And if you multiply the bottom one by 5, that gives us 5x plus 35y equals 25 times 5, that's 125. So that's the two equations that we'll be working with. Now we can add or subtract it to eliminate one of these, and we're going to eliminate this matching pair here, the two 5x's. And since they have the same sign, we can subtract them, and that will cancel these out, leaving us with only the y's. So 2y minus 35y, that's going to give us negative 33y equals negative 7 minus 125. I'm just going to quickly put that in the calculator. Negative 7 minus 125, and that gives us negative 132. Now let's get rid of the negatives. That gives us 33y here and 132 here. And y equals 132 divided by 33. Quickly do that. And that gives me 4. So y is going to equal 4. Now let's substitute 4 into one of these equations to get to solve for x. I'll just do it over here because I'm out of space. So y equals 4. I'll substitute that in. 5. I'll just do it into the top equation here. 5x plus 2 times 4 equals negative 7. 5x plus 8 equals negative 7. 5x equals, got to subtract 8 from both sides. That gives us negative 15 here. So x will equal negative 3. Alright, now moving on to the next question on the top right. I'll just write out this working out. If you do need to go back and look at the working out, just rewind the video a little bit. And let's have a go at this one now. So we have 4x plus 3y equals 18 and 3x minus 2y equals 5. So in this case, I'm going to make the y's even, or matching pair, by multiplying the top by 2 and the bottom by 3. So that gives me 4x plus 6y. Sorry, that's not 4x. I know I multiply that by 2 as well. That's 8x plus 6y equals 18 times 2. That gives me 36. And multiply the bottom one by 3. 9x minus 6y equals 15. And now since they have an opposite sign this time, or different signs, we can add these to eliminate them. So that cancels out. 8x plus 9x, that gives me 17x equals 36 plus 15. I'll quickly do that over here. 51. And x will be 51 divided by 17. I'll quickly put that into the calculator. That gives me a value of 3. So x equals 3. Now I'm going to substitute x into one of these. I'll do into the bottom one this time because the numbers are a little bit nicer. So 3 times, substitute 3 into x. That gives me 3 minus 2y equals 5. 9 minus 2y equals 5. Bring the 9 over by subtracting it on both sides. So negative 2y is going to equal negative 4. I'll continue my working out up here. Divide both sides by negative 2, so y will be 2. So our two final answers is x equals 3 and y equals 2. So now let's have a go at the question on the top left here. So we have 7x plus 2y equals 12 and x minus 3y equals 5. And the fastest way to get them to get a matching pair from these two equations is to multiply the bottom one by 7. So its top one stays the same. We don't do anything to it. Still say 7x plus 2y equals 12, and the bottom one becomes 7x minus 21y equals 35. Let's ignore that. So since they have the same sign here, we can subtract them to get rid of these, and 2y minus negative 21y is the same as 2y plus 21y because we have two negatives. So that becomes 23y equals 12 minus 35. That will give us negative 23. Now divide both sides by 23 to get y by itself, and that will give you negative 1. Now that we have y, let's substitute into any one of these equations. I'm just going to use the bottom one since it's a bit nicer to work with. So x minus 3 times negative 1 equals 5. So x plus 3 is going to equal 5, and x therefore equals 2. So our final answers are y equals negative 1 and x equals 2. Give yourself a tick if you got this one correct. Just a quick tip, if you're ever unsure if you're correct, you can substitute these values into your equation, into one of these equations to check if you're on the right track. So just to show what I mean, I'm going to substitute x equals 2 into one of these. So 2 minus 3y equals 5, and your y should equal what you worked out before. So that gives us negative 3y equals -3, and y will be, sorry, my bad, 5 equals 3. 5 minus 2 equals 3. I'll just fix that up. And y will be -1 if we divide -3 from both sides. So from this, we can see that our x is correct. So in the future, if you're taking a test or anything, you can substitute your value in just to double check if your answer is right or wrong. Alright, so now let's jump to the question on the top right. Once again, I'll just rub out this working out. If you need it, just go back in the video. So this question is 3x plus 2y equals 5 and 5x minus 3y equals 21. So in this case, I'm going to multiply this by 3 and that by 2, so we get y's as a matching pair. So that gives me 9x plus 6y here equals 15, and 10x minus 6y gives me 42. So these, we can add these since they have opposite signs here. So these two cancel out. And 9x plus 10x, that gives me 19x. And 15 plus 42, that gives me 57. So now we have to divide both sides by 19. I'll just quickly do 57 divided by 19. And that gives me x equals 3. Now I'll substitute x into the top one. So 3 times 3 times 3 plus 2y equals 5. 9 plus 2y equals 5. And then subtract 9 from both sides. That gives me 2y equals -4. So y would equal -2. Now just to check if my y is correct, I'm going to substitute that into the top one. So I'll just quickly do that. 3x plus 2 times -2 equals 5. 3x minus 4 equals 5. 3x equals 9. X equals 3. So from substituting that back into the equation, we found out that our answers are correct. So if you got x equals 3 and y equals -2, give yourself a tick. Alright, so now that brings us to the end of this lesson. Hopefully you guys know how to solve simultaneous equations using elimination, and you can add or subtract two equations to eliminate one of the variables. Also know how to obtain a matching pair in simultaneous equations like we were doing the last few slides, and also finally be able to use elimination to solve simultaneous equations. Once again, thanks for watching guys, and I'll see you guys back online.